My name is Kelly Powell, and today I want to review the case study number 28, a root cause analysis, production loss, temperature, and the process. The process is a rotating process dryer for making a paper product. Lots of temperature during operations causing issues with paper product quality and reject. The dryer surface temperatures are inconsistent. Therefore, review for the operation, installation, safety compliance. One of the things that we noted was the need to install functional pressure gauges on the steam supply to determine what the exact pressure is to the dryer system that's located right here. There was a question, because of the different pressures in the system, what exactly was the pressure at the inlet to the dryer, which was located after a control valve. The next thing we notice is that the valves here, which are a ball valve, are not rated for the pressure and temperature, which is a code issue. The next thing we looked at in the system was the flex hoses that they are currently using here. The inlet and the outlet connections here are reduced. And if we want unrestricted flow of steam to the rotating dryer, unrestricted flow coming out of the dryer. The other thing in investigation of the steam hose, we found the internal diameter was reduced for a number of manufacturing reasons, so that's also restricting the flow. So a couple things is the diameter of the hose is reduced and the connections here are reduced. If the connection is 1.5 inches, we want 1.5 inch hose. And the next thing in our investigation of hose, it does not meet B31.1 code requirements. The other thing, all hoses have to be code compliant to B31.1, which is the National Power Piping Code. The other thing is that coming off a rotating dryer, we want to drop down further to kind of assist on the evacuation of a rotating dryer, because we are defying gravity with the dryer, because condensate gets all processed by gravity. Here we're defying gravity. We're coming through the center part of the rotating dryer. The next thing, in looking at the system, there is a strainer here. This is the condensate drainage coming down here. The strainer needs to have a blow-off valve on the strainer. We've had to shut the system down, take a look at the strainer, and it was, probably around 40% plugged. The next thing was the isolation valves here. Again, they're gate valves, and we prefer ball valves for that installation. The design of the steam trap is a proper design for this application, which is a floating thermostatic design steam trap. However, in evacuation of a rotating dryer, we do need to have blow-through steam, which is usually accomplished by a needle valve around the steam trap, so a small percentage of steam is allowed to flow through. This assists the evacuation of the condensate from a rotating dryer. The other thing is, on these systems, there's multitude of threaded connections, which are always a weak point in the steam system. And a leakage point, not on this system here, but on a couple other systems we looked at, the threaded connections were leaking. Next thing is there's a check valve located in after the steam trap, and the question was the pressure drop across the check valve. The thing with this system, there was no need for a check valve. They have proper startup and shutdown procedures with this, therefore there's no need for a check valve because backflow is not going to occur. The other thing is there should be, again, pressure gauges, here, and I would suggest a pressure gauge on the inlet coming to the steam trap so we know what the pressure differential is. the short term, what happens tomorrow? We always say what happens tomorrow. Short term, replace the steam hoses that are correctly sized and code compliant. Correct the steam trap orifice to the correct orifice. We found that the steam trap is the proper design, but it had the incorrect orifice into it, which was limiting the condensate capacity. We attached technical data sheets to this email back to the plant for corrective action. Isolation valves need to be removed and replaced with code compliant valves. It's a safety issue, not code compliant. Install proper pressure gauges for verifying steam and condensate system pressures. Install a ball valve on the existing strainer and have PM blowdowns of the strainer to make sure we don't get pluggage again. And remove the check valve, which is not needed for this application. Long term, install ball valves for isolation. As you can see, this here, the isolation valves, this is a system called a universal connector steam trap station. It's got the strainer built in with the strainer blowdown valve, steam trap using tubing and tube connectors, thus eliminating the leakage. And that's a common steam trap station. If there's any questions, please contact me at my email or give me a call, and we can have a conference call discussing this situation. Thank you for your time, and have a great day.